sampling distributions. Sampling distributions. This is the topic for the next two videos, including this video. Basically, a sampling distribution sampling distributions are distributions that arise as functions of data, right? And in this course, I will talk about two such distributions. The first one is known as the chi-square, and is denoted by this Greek letter chi. The second one is known as the student's t, and is denoted by little t, right? And in this video I will talk about the chi-square distribution, and in the next video I will talk about the student's t distribution. Okay. So here I will talk about the chi-square distribution. I will explain in a couple of minutes why this distribution is a sampling distribution. In other words, why this arises as a function of data, right? But before that, let me give you some other stuff, right? So a random variable x as the chi-square distribution with parameter a if its probability density is a chi-square distribution is a continuous distribution, so we talk about the probability density function. Okay, so this is the probability density function of a chi-square variable, and it's defined on the positive real line, and the only parameter a is also positive, and a is referred to as the degree of freedom parameter, so it's degree of freedom parameter, right? Okay, typically the shape of a chi-square density, we should plot this versus x. It will look something like this. So this is your x-axis, right? And excuse me, and this will be your density axis. So this is the density f of x, and this is x, right? And this is the PDF of this is typical shape of a PDF of a Chisquared variable. Right? Right. Now, next thing, I want to give you some ArtMonths. So these are the first thing is about the PDF. Right? The following command DCHISQ command df equal to say 2. So df here stands for degree of freedom. So then the number 2 refers to the value for a. Right? So this command computes the PDF of a Chisquared variable with 2 degree of freedom, right, with a equal to 2, right, at x, right, okay, and this command here, PCHISQ open bracket x comma df equal to 2, it computes the CDF of a Chisquared variable with 2 degree of freedom at x. Okay. So these are the R commands. Okay. And the next thing I like to talk about are percentiles. I don't know whether you know what percentiles is, but percentiles is something that will be useful later on in this course. So percentile for a Chisquared distribution, the percentile is denoted by the following notation. Right? So this is the definition, by the way. So the definition, this is the value satisfying the probability that equal to alpha. So for example, if I draw the density function for a Chisquared distribution, suppose it looks like this. Suppose this is the density of a Chisquared. So this value here, what is the value for which the probability that the variable is less than or equal to is alpha. So for example, suppose this area here, suppose this area is alpha, right? Then according to this definition here, this point here must be this. So in other words, it's the point to the left of which the area is equal to alpha. So here we are talking, this is the PDF of Chisquared A. Okay. You follow me? So the percentile is defined on the horizontal axis as the value to the left of which you have an area of alpha, right? There are There are tables for reading the value for this. Okay. So for the chi-square distribution, let me show you the table. This is the table for the chi-square distribution. And you can use this table to read values of the percentiles. So for example, suppose you want to find the percentile of a chi-square distribution with 2 degrees of freedom when alpha is 0.95, right? So to read this, what you do is you go to this table, right? And you look for P equal to alpha. You look for P equal to 0.95, and then the degree of freedom is 2. So it's 2 and 0.95. So that gives you this number here. So this guy here will be equal to 5.991. Right? So in other words, what this means, what this actually means is that the probability that a chi-square variable with 2 degrees of freedom less than or equal to 5.991 is equal to 0.95. Another example, suppose you want to find the percentile of a chi-square variable with 15 degrees of freedom for alpha corresponding to 0.01. So once again you go back to the table, right? In this case you will look for 0.01 and then down to 15. So that will give you this guy here, which is 5.229. So the answer is so which implies that the probability that a chi-square variable with 15 degrees of freedom less than or equal to 5.229 is equal to 0.01. So it's very easy to read. I mean, you should know how to read this table in an exam, right? So there's just one row. This is one column which gives you the degree of freedom, and this gives the value for alpha, which in the table is called P, right? It means alpha in my notation, right? So, okay, guys. The next thing I want to talk about, I want to give you some properties of chi-square variable. First property is that the expected value is equal to the degree of freedom. The second property is that the variance is 2 times the degree of freedom. And third property is this: if IID means independent and identically distributed normal variables with 0 mean and variance sigma squared, right? Then the following result is true. I mean, this result, you may remember at the beginning of this video I said that I was going to show you that chi-square distribution is a sampling distribution, which means it arises as a function, as a distribution of a function of data, right? Okay, this is precisely why the chi-square distribution is a sampling distribution. Because if you look at the left-hand side, okay, the left-hand side is the function of data only. I mean, there's nothing on the left-hand side that is not data, right? Okay, and the right-hand side is the chi-square distribution. Right. So this is what I meant earlier, that chi-square distribution arises as a distribution of the function for data. That's exactly what's happening here, right? So this is exactly why this is exactly why that chi-square is a sampling distribution. Right? So that's property 3. Now property 4. If you have two independent chi-squared variables, the first one with degree of freedom A, the second one with degree of freedom B, then their sum, x plus y, will also have a chi-square distribution with A plus B degree of freedom. Okay? So that's property 4. Property 5. If x is a standard normal variable, then x squared is a chi-square variable with 1 degree of freedom. Right? So that's property 5. Now, next, property 6. Right? If you have independent normal random variables with parameters mean, parameter mu, and variance sigma squared, then the following statement is true. That is, the sum is a chi-square distribution with n degree of freedom, right? Okay. All right. So these are the 6 properties I would like to give you. Once again, there's no need to no need to know the proofs of these properties, right? You only need to know how to apply these properties, not the proofs. Okay? The next thing I'm going to do before completing this video is to do an example. All right, so I'll just do one example. Right. The question is to calculate the probability that s squared is greater than 3, where s squared is 1 over n is the sample variance. Remember, there are two formulas I gave you for the sample variance. I'm using the second of the two formulas, and this is known as the unbiased version of the sample variance, right? Okay, so let's see how we can do this. So we want to find the probability that s squared is greater than 3, right, which is the probability that 1 over n minus 1 is greater than 3. Okay. Now this we can write as like this, right? Now I'm going to use one of the properties I mentioned in the previous slide, which says that this guy here, right, has a distribution which is sigma squared. Sigma squared in this case is 1 squared, which is 1 times chi-squared n minus 1. So this becomes chi-squared n minus 1 greater than 3 times n minus 1. So this is by property 3. By the way, one thing I must say here is that here you have a normal variable with mean equal to 1 and variance equal to 1. When I stated property 3, I said that the mean is equal to 0, but property 3 still holds if the mean is not equal to 0. So the property 3 is also true if mean is not equal to 0. Right? So we can still apply property 3 although the mean is not equal to 0. Okay. Alright, I just wanted to make it clear. So this is 1 minus the probability that chi-squared n minus 1 is less than or equal to 3 times n minus 1. Right, and this is 1 minus, let's say f. I'm going to use the notation here to so here where denotes the CDF of a chi-squared variable, than -1 degree of freedom. Okay, so this completes the example and also completes the video on Chisquared distribution. And in the next video, I will talk about the second of the two sampling distributions, which is known as the student's T distribution.